Hey everybody, Mr. Kowalczyk here. So we're going to start off today with Hypotenuse Leg Shortcut, Geometry Unit 8, Lesson 2. Again, the QR code here is for extra help if this lesson doesn't do enough for you. Now, standard 16.1, again, we are going to be jumping in here with, this is going to be standard 12.3. Okay, standard 12.3 for hypotenuse leg. I can show two right triangles are congruent by the hypotenuse leg shortcut. So yesterday we talked about several shortcuts. We talked about side, side, side. We talked about side, angle, side, angle. And we also talked about angle, side as ones that did work. We also talked about two that did not work, where the first one was angle, angle, angle. And we also talked about the fact that there's no ass in math. So angle, side, side does not work either. So both of those are not adequate shortcuts. That takes us into our opener. Are these two triangles congruent? Why or why not? Take a minute, please. Look at them and explain why or why not you think that they're congruent. All right, hopefully you recognize that here we have angle A being congruent to angle D, and then we have side AB being congruent to side DE, because they both have two tick marks. And then we also have side BC being congruent to side EF, because they both have one tick mark. However, if we start here at the angle, then we're going to move right along to the side, and then the side right there. So that gives us angle, side, side. And we see here that the shortcut there is angle, side, side, which means it's ass, and there's no ass in math. So therefore, these two triangles cannot be proven congruent yet. We just don't have enough information. So they fit the angle, side, side shortcut. And therefore, remember these three dots in a triangle mean therefore cannot be, and therefore congruency cannot be determined. If we have more information about these triangles later on, we might be able to, but for now we can't determine it. They also don't look congruent visually, but they might not be drawn to scale. Okay, let's go ahead and jump into the notes here. For our vocabulary for today, we've got hypotenuse. Now, the hypotenuse, the definition, as some of you probably remember, is the longest leg of a right triangle. It is also opposite the right angle. So in our right triangle, we've got a right triangle here. I'll try to make this as right angle looking as possible. And we have our third side here. Now in our right triangle, we've got three sides, 1, 2, and 3 sides. Here we've got our short, here we have our longer side, and here we have our hypotenuse. Okay, it's opposite the right angle, and it's also the longest leg. It's always going to be the longest leg. Okay. So a reminder about what that hypotenuse is. All right, next, hypotenuse leg shortcut. Now, we said earlier that while ass is not valid in general, there's a special case for right triangles. And it only applies to right triangles where we can use angle, side, side. Let me show you what I mean. The shortcut is hypotenuse leg shortcut, or HL. And this is going to be our fifth and final shortcut for proving triangles congruent in Unit 8. So you don't have to remember any more. We've got the 4 up top, and now our last one is going to be hypotenuse leg. So let me show you what I mean by hypotenuse leg. So we have two triangles. Please go ahead and draw two right triangles that are approximately the same size so they can look congruent and you kind of look at them. Okay. And then we'll go ahead and label these. You can label them with whatever letters you want. We'll label this one CAB. And this one here we'll call SLX. Okay, now we have triangle CAB and triangle SLX. If we are told that these two sides are congruent to each other, and one of the other two sides are going to be congruent to each other, then we can prove, based on the shortcut, that the triangles are congruent. I did forget up here, just occurred to me, sorry, that in a right triangle, we have our hypotenuse here. We also have legs. Each one of these is referred to as a leg. Okay, so please add those to your notes. Sorry, I didn't include that up above. So now what we have here is we have, first off, we need to know that we have, for the hypotenuse leg shortcut, we need to know three things. First off, we need to know that we have a right triangle. Check. Secondly, we need to know that we have congruent hypotenuses. And third, we need to know that we have congruent legs. And in this situation, we have right triangles. Check. Do we have congruent hypotenuses? Well, both of the hypotenuses are across from the right angle, and they're congruent to each other because they have one tick mark. Check. Now, the third one, do we have a congruent leg? So what I notice is that either of these, LX and SL, are both legs. CA and AB are both considered legs. Do we have congruent legs? Yes, we do, because these two sides are congruent to each other. Therefore, triangle CAB can be congruent to, let's go ahead and do this. This side doesn't have any tick marks on it. So I'm going from C, which is at the hypotenuse here, to across the side that doesn't have any tick marks to the right angle. So my third point that's left over is B. So I have to go from C to A to B. So I'm going to follow that same pathway in the other triangle to make an accurate congruency statement. I start up here at S, which is right next to the hypotenuse, and I go down the side that has no tick marks to the right angle, L. And then my third point is going to be X, triangle SLX. All right, so that's how hypotenuse leg works. That's all there is to it. Let's go ahead and do some sample problems. Okay. Up here in class, we'll have a conversation, and then you're going to have the opportunity to answer this question on your own. If you think you have an idea now why hypotenuse leg works when regular ASS does not, go ahead and fill that in. Maybe you can share it in class. For now, we're going to leave that blank. We'll come back to it in class and talk about it together. Let's go ahead and jump down to number 2 for our sample problem. Now, is there enough information given to prove the triangles are congruent by hypotenuse leg shortcut? So let's go ahead and take a look at this here. Now, first off, I said the three things that we needed to know were, do we have a right triangle? Yes, we do have right triangles because we see the two right angles there. Second, do we have congruent hypotenuses? Well, the hypotenuses are right here and right here. We have PQ and RS. And right now, as the diagram stands, they're not congruent to each other. So that's problematic. Let's keep looking at this diagram and see what else might work. Well, we know that we have congruent legs because here it says that ST is congruent to PT and RT is congruent to TQ. So we've got those working together. However, here's another interesting thing that we can look at. If we look at these triangles together, what we see is that we have one congruency tick mark, an angle, and two congruency tick marks. Well, that looks like angle, side, angle. Sorry, I take that back, side, angle, side. And then this one here follows the same pattern. We have one tick mark, right angle, two tick marks. So actually, what we can do is we can say that triangle, let's go ahead and start with S and go to T to R. S, T, R is congruent to triangle PTQ, PTQ by side, angle, side. Now what we can do with this is if the triangles are congruent, then the hypotenuses must be congruent also. So then, knowing that, we can prove the two triangles congruent by hypotenuse leg because we have hypotenuse and we have leg in our right triangles. So in this situation, you wouldn't be wrong if you said, is there enough information given to prove the triangle is congruent by HL shortcut? You could say no, because in the original diagram, you're not given enough information just to prove it congruent with hypotenuse leg. You first have to prove them congruent by side angle side. Then you can prove that the two triangles are congruent by hypotenuse leg. So actually in this situation, you could say, yes, there is enough information given to prove the triangle is congruent by HL, because after you prove them congruent by side angle side, then you can prove them congruent by HL also, which is kind of redundant because you've already proven them congruent. So this situation requires us to prove the triangles congruent by side angle side first. Then we have enough info to prove congruency by HL. So it's kind of a yes, it's kind of a no. I like this problem a lot because it doesn't have a very clear answer. Sometimes that's really cool in math. Okay, so number 2. Obviously, you're going to need to do number 1 on your own. That one's going to be a bit more straightforward than number 2 for sure. Let's go ahead and skip over and we'll jump into number 4. Now, number 4 has some given information, which means they're telling us what's true in this particular problem. ME is perpendicular to BA. Remember, this symbol means perpendicular to, which means that it makes a right angle. So here we have ME being perpendicular to BA, which tells us that all of these angles, these 4 angles here, are right angles. So that makes these 2 triangles a right angle and right triangle, excuse me, which checks off the first situation that we need. Do we have a right triangle? Yes, we do. Now, secondly, let's go ahead and look here. MA is parallel to EB. MA is parallel to EB right here. Okay, that's interesting. What does that tell us? It tells us that we have some congruent angles because we have alternate interior angles. If we consider this ME a transversal, it tells us that this angle here is going to be congruent to this angle here. Parallel lines and a transversal make congruent angles. Now it also tells us if we look at BA as a transversal, it tells us that this angle here is congruent to this angle here. All right, now is MYA congruent to triangle EYB by HL? Well, first off, do we have a right triangle set? Yep, we do. Secondly, do we have congruent hypotenuses? Well, this is going to be the hypotenuse, right? It's opposite the right angle. But we don't know if they're congruent. In this situation, how do we know if the triangles are congruent? Well, we have angle, 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 angle that are matching up with each other. But we already said on the previous page that angle, angle, angle doesn't work. Okay, do we have congruent legs? We don't really have any information whether or not the legs are congruent to the legs in the other triangle. So in this situation, all we have is information about the angles. We don't have any information about whether or not the sides are congruent to each other. So we can say it cannot be determined because we just don't have enough information. We don't know if the hypotenuse is congruent. We don't know if the legs are congruent. All right, let's go ahead and do one more together, and then you can work on the rest of the practice problems in class. I'm going to do number 5. Let's read the instructions first. For the following problems, label the vertices of the triangles. State if the 2 triangles are congruent by HL. If they are, write a congruency statement. If you're unable to determine congruency, write not enough information. Okay, so first step, we have to label our vertices. Let's start with A, B, and I'm going to go with W and X, just some various letters. All right, now we have two triangles here, up here and down here. First question we need to ask, do we have a right set of right triangles? We do, because we know this is contiguous. So therefore, this is also going to be a right angle right there. So we have two right triangles. Now, what else can we determine from this picture? Well, we know that AB is a shared side, so that's going to be congruent in both the upper and the lower triangles. All right, cool. So now let's go into our checklist. Do we have right triangles? We do. Check. Do we have congruent hypotenuses? Well, the hypotenuses are going to be opposite the right angle, AW and AX. We do have congruent hypotenuses because AX is congruent to AW. And secondly, do we have congruent legs? Well, XB and BW could be congruent legs. We don't have any information about those, but we have information about AB. AB is a shared leg in both the upper and the lower triangles. So because we have congruent hypotenuses and because we have congruent legs, we know that these two triangles are provable congruent by HL. So therefore, we'll say that triangle ABX is congruent to triangle ABW. All right, we're going to stop there for today. And then we'll work on the rest of the practice problems in class tomorrow. All right, have a great night, and hope this was helpful.